Hello and welcome to the first lecture for linear algebra. Today we will begin chapter 1, which is linear equations in linear algebra. So in this chapter we will learn about systems of linear equations to introduce some central concepts in linear algebra. Sections 1 and 2 will explain one method for solving systems of linear equations. Sections 3 and 4 will show how a system of linear equations is equivalent to a vector equation and a matrix equation. This equivalence will reduce problems involving linear combinations of vectors to problems involving systems of linear equations. Again, if you don't know what any of that means, I'm just giving you a basic summary, and you will definitely know what all of that means specifically in terms of equations by the time we get through chapter 1. Okay, so let's get started with sections 1.1 and 1.2. We will start with systems of linear equations. So first let me give a definition. A linear equation with variables x1, x2, x sub n is an equation of the form a1 x1 plus a2 x2 plus ... plus an xn equals some value b, let's say. Now this equation is linear because, as we see, none of the variables has squared or cubed or, to the power 1 over 2. They don't have that. And they are all 1 to the power 1. Okay? So that's what makes them linear. So examples include, y equals 2x plus b, or let's say plus 3, y plus 3x equals 4. These are examples. Or if I have, let's say, x1 minus 2x2 equals 3, these are linear equations. Okay? Now, why is this one a linear equation? Well, because we can make this look like y minus 2x equals 3. And the variables are y and x, but we see that they are both to the power of 1. So therefore, this is a linear equation. And the variables, in this case, are x and y. This is also a linear equation with variables x and y. And this equation here is a linear equation with variables x1 and x2. Okay. So now that we know what a linear equation is, what is a system of linear equations? Well, a system of linear equations is just a set of linear equations, or a list of linear equations, a collection of linear equations, if you will. So, for example, this is a system of linear equations here. This is a system of two linear equations. With two variables, x and y. This is another example of a system of linear equations. A system with, we see 1, 2, 3 variables, with 3 variables, x1, x2, and x3. Okay? So these are examples of systems of linear equations. Okay? And a solution for a system like, let's say 2, is a set x1 equals some number, x2 equals some number, and x3 equals some number, so that if we plug in x1, x2, and x3 into each equation, then we will get true statements. Okay, so if this is confusing, don't worry. When we do an example, it'll be a lot more clear. So let's do an example where we have, let's say, x minus 2y equals -1, and negative x plus 3y equals 3. Here's a system of linear equations. Two equations with two variables, x and y. And we want a solution, x equals and y equals something, something, right? Okay, so you've probably seen an example like this in high school. And here's how we can do, if we didn't know anything else, here's how we can do this problem and find a solution, an x and a y, so that if we plug in x and y into both equations, these two statements will be true. So what I can do here is I can take the first equation and say x minus 2y equals -1. So I plus 2y on both sides. And I get x equals 2y minus 1. And then from this equation here, I get negative x plus 3y equals, what I'm going to do here is I'm going to take this x here and I will plug it in for this x right here. And when I do that, I get negative 2y minus 1 plus 3y, you see, equals, we have negative x plus 3y equals 3. So we have equals 3. Okay. And now we can just solve for y. So this is negative 2y plus 1 plus 3y equals 3. This leads us to y plus 1 equals 3, y equals 2. Okay? And now we can take this y equals 2 and plug it into any one of these equations to find x. So let's do that. We have x minus 2y equals x minus 2 times y equals 2, which is equal to negative 1. So we get x minus 4 equals negative 1. Therefore, x equals 3. Okay? Okay. So in this example, we are given a system of linear equations, two linear equations, and we are asked, what is the solution? Well, the solution is an x and a y, so that both of these equations are true. Okay, so that I can plug in x equals, so check this out. I can take this first equation here, and say x minus 2y equals negative 1. And I can plug in x equals 3 and y equals 2. So I'll have 3 minus 2 times 2 equals negative 1. And so I have 3 minus 4 equals negative 1. This is true. And I can take the second equation and say negative x plus 3y equals 3. And then I can take x and y and plug them in to this equation. And I will get negative 3 plus 3 times 2 equals 3. Is this true? I have negative 3 plus 6 equals 3. That's true. So yes, y equals 2 and x equals 3 is a solution for both of these equations. Okay? And that's what it means for a system of linear equations to have a solution. Okay. So this is linear algebra, and I'm sure that this is not a difficult problem for almost all of you. I know that most of you can, if I give you a system like this, you can give me a solution like this, okay? But this process right here of finding this solution is too long. There's another way we can do it that makes it a lot faster using what we call a matrix, which I'll show you how to do in a little bit in the next section. But before we do that, let's think about what this means geometrically, right? So we have a system, x minus 2y equals negative 1, and negative x plus 3y equals 3. What do these two mean, these two equations? What does this equation represent geometrically? We know geometry. Geometry is, the mathematical study of shapes. So, lines, parabolas, circles, rectangles, things like that. So, what kind of shape does x minus 2y equals negative 1? What is the shape of this? Well, I can rearrange this to look like, if I do plus 2y plus 2y, I get x equals 2y minus 1. And then I want to do plus 1 plus 1. I get x plus 1 equals 2y. And now I divide by 2, and I get y equals 1 over 2x plus 1 over 2. Okay. So, and if I want to do the same thing here, what I will get is y equals 1 over 3x plus 1. Okay. Now if I look at these two and I ask you, what is their shape? You should know, oh, this looks like y equals mx plus b. And y equals mx plus b, when we graph it, is a line where this value is b and the slope is m. Which equals, y2 minus y1 over x2 minus x1, right? So if I ask you, what is this shape of this equation here, you should say the shape is a line. And you should know how to graph this line as well. Okay. So let's go ahead and graph both of these lines and see what does it mean for this system to have a solution. So here, sorry. Okay. So we want to graph y equals 1 over 2x plus 1 over 2. Well, when x is equal to 0, y is equal to 1 over 2, right? When x is equal to negative 1, y is equal to 0. And when x is equal to 1, y is equal to 1. So let's plot these points. We have 0 for x. We have 1, 2. So we have 0, 1/2. So 0 in the x direction and then only 1/2 in the y direction. And then we have negative 1, 0. Well, actually, this is negative 1. This is negative 1/2. Right? And then we have 1, 1. So we basically have this line here. Okay? And this is y equals 1 over 2x plus 1 over 2. And now we want to graph this line here. So when we do that, we'll have x equals 0, y equals 1, x equals negative 3, y equals 0, and x equals 3, y equals 2. So we'll have y equals 2, x equals 3 will be like up here. Okay. Actually, the 3 will be up here. So actually, I can do more numbers here. And when I graph this one, what I will get is something like this. So I have 0, 1. It goes through 0, 1, this point right here. So the line will give me something like that. Actually, it'll actually give me something like this. Where it's actually 1, 2, so I'll have 1 here, 3. Okay. So basically, I have these 2 lines, and when I graph them both, I see that the point of intersection is where x equals 3 and y equals 2. If we look here, that's exactly what our solutions were to the system of linear equations. So basically, if I give you a system of linear equations with 2 variables, then each one is a line. And a solution is the intersection of the 2 lines. Okay? So now you know algebraically how to find a solution for a system of equations like this. And you also know a system of equations like this represents 2 lines in space, and the solution represents the intersection of the lines. Okay. So what have we learned so far? We've learned what is a system of linear equations. We learned what variables are. And we learned if we have a system of 2 equations and 2 variables, like this one right here, then we can find a solution by finding a y and an x that will work for both of them. Okay? And geometrically, what is the solution for a system of linear equations like this? Well, a system of linear equations like this with 2 equations and 2 variables represents 2 lines in space, these 2 lines right here, okay? And the solution represents the intersection of the 2 lines. Now, this idea of going from algebra to geometry, then back to algebra, is very important in linear algebra, and it's very important in all of mathematics actually, and it's important for engineers as well, because engineers a lot of times they deal with shapes, with complicated shapes, and they need equations to be able to calculate things about shapes. We're going to see examples. I'm not just going to give you this general overview. We're going to see examples of when this is very important for solving problems in engineering. Okay, so that ends the first part of this lecture that I wanted to start for section 1.1. But before I do that, think about this. If I have a system with 2 equations, ax plus b y equals c, and dx plus ey equals f, where x and y are the variables. Okay. How many solutions can I have to this system of equations? Well, if I think about it, what is a solution for a system of equations? A solution is the intersection geometrically. So this is a line, this is a line. How many ways are there for a line to intersect? Well, I could have, for example, two lines. One of them is like this, one of them is like that, and there's one intersection only. I could have two lines like this one and this one, which are parallel, and there will be zero intersections. Or I could have a line like y equals x, let's say, okay, and I could have another line, let's say 3y equals 3x, which is exactly on top of this line. Okay, so in this case, I have how many intersections? Everywhere. Everywhere is an intersection, right? So I will have infinite solutions. Or I could have a situation like this where I will have zero solutions. Or I can have a situation like this where there is exactly one solution. And we will see in the next section how any system of equations has either zero solutions, one solution, or infinitely many solutions. And this is for any system, not just a system with, two variables and two equations, but even if it had three variables and three equations, four variables and three equations, no matter what, it will only have either 0, 1, or infinitely many solutions. And we see why in two dimensions for an equation with two variables and two equations. We see why it will either have 0 solutions or one solution or infinitely many solutions. And in the next class, or in the next lecture, I will explain if you have a system with three variables and three equations, geometrically, how can we see that there are only either 0 solutions, one solution, or infinitely many solutions? I'll explain that in the next class.